All right, day 3, so 7.3, we are going to start off with another, it's a pretty tough proof. So you guys did really, really well with your rhombus yesterday when we proved that it was a parallelogram. So today we are going to work with rhombus again. Like I said, it's going to be a lot of steps, but we'll get through it and you guys will do just fine. So number 1, yesterday you proved rhombus is a parallelogram because the opposite sides are parallel. Today you'll prove the diagonals of a rhombus bisect each other. So the first question is, what does bisect mean? So this should be in your notebook. Go ahead, check out the definition in your notebook, and go ahead and write it down on the paper. I am not going to write it down in mine because I know you guys all took the notes yesterday. Otherwise, they are on Google Classroom, and you can write down the definition from there. So given PQRS is a rhombus, the diagonals, and then we want to prove that the diagonals of a rhombus bisect each other. So step 1, we got to draw the diagonal PR. So I drew the diagonal PR, then I draw the diagonal QS, and then label the point where they intersect as point T. So make sure your picture matches mine. All right, and then looking at the bottom part of this, it says, if you can prove that triangle PTQ is congruent to RTS, you can then use CPCTC to show that ST is equal to TQ and PT is equal to TR. Do it. Just be ready to present your proof to the class. So you guys won't be presenting this, and I'll kind of help you walk you through it. So let's start with our statement reason table. So let's start with what we are given, and you can see here it says exactly what we're given. PQRS is a rhombus. So number 1, PQRS is a rhombus. And that's going to be given. Step number 2, remember that yesterday we proved that it is a parallelogram. So we know that it has the same properties as a parallelogram. So we know that PQ is going to be parallel to SR. And we know this because that is the definition of a rhombus. Actually, that was put it over here. Definition of a rhombus. All right, so we know that PQ, we draw a little parallel symbol, the arrows, so we know that those two are parallel. And we also know the other set of parallel sides as well. So we know that PS is parallel to QR. Go ahead and tell me the reasoning for here. This is going to have the exact same definition, or this exact same reason, which is definition of a rhombus. We should show our flow here as well. So we know that number 1 says that it's a rhombus. So this number 2 comes from step 1. Okay. So we know that we can use definition of a rhombus because those are coming from step 1. All right, now since we know we have parallel, what does that mean about some of our angles? So let's do step 4 here, and let's set up a pair of angles that we know must be congruent. All right, so we know that angle QPR must be congruent to PRS, so we know that these two angles must be congruent. And how do I know that those two have to be congruent? Please give me the reasoning. And my reasoning here is going to be, if there's parallel lines, then alternate interior angles are congruent. And I know there's parallel lines because of step 2. So step 2 says that PQ is parallel to SR. So I'm going to show the flow by putting that 2 in parentheses. Step number 5. We now have a separate set of angles. So angle PQS is congruent to RSQ. Once again, go ahead and tell me how we know those are congruent. And our reasoning for number 5 is going to be, if parallel, then alternate interior angles are congruent. So the same reasoning from number 4, and once again we know that these two lines are parallel from step 2. So we have two angles. We need one more thing to prove congruency. So we can also state that PQ is congruent to RS. Right, so we can state that PQ is congruent to RS. What is our reasoning for that one? That's going to be the definition of a rhombus again. So remember, our definition of a rhombus says all sides are congruent. So therefore, PQ must be congruent to RS. All right, step 7. So then step 7, we can say that triangle PTQ is congruent to RTS. Put that up. And how do we know those triangles are congruent? What triangle congruency theorem is that? It's going to be angle side angle. So we proved the first angle with step 4, and then we proved that side in between the two angles in step 6. And then to prove that last angle, we use step 5. So steps 4, 6, and 5. Perfect. Now we can move on to step 8. And kind of look at your definition too for help here for kind of what we're doing. So the next thing we're going to say is ST is congruent to TQ. And what's my reasoning for that one? Remember what we did yesterday to help you out with that. So it's going to be corresponding parts of congruent triangles are congruent, or CPCTC. Okay. So we now know that these are congruent. And to show our flow, we have to say which step that we prove triangle is congruent. That was step 7. Step 9, we're going to say the other diagonal. So PT is congruent to TR. And go ahead and give me the step or the reason for that one. CPCTC again. And we have to put the step that we know that they're congruent, step 7. And so we're done with our proof. We have everything we need. So remember what we're trying to prove is the diagonals of a rhombus bisect each other. So I'm going to put that into my proof. So for number 10, the diagonals of a rhombus bisect each other. And for my reasoning for this one, don't overthink it. Don't overthink it, but take your best guess. All right, so that's going to be the definition of a bisect. So remember, bisect splits things into two congruent parts, two equal parts. So now we have point T that split this into two equal parts and this into two equal parts. So definition of bisect, and then we have to show our flow. So where did we have our steps where we put stuff into two equal parts? Well, step 8 was when we stated that these two were congruent, and step 9 is when we said those two were congruent. So it would be step 8 and 9. Right, and there is our proof that the diagonals of a rhombus bisect each other. Nice job on that. That is not easy at all. So if you did well on this video, congratulations. You definitely truly earned that. Go ahead to the back side. It's a little bit easier, a little bit less thought-provoking.